Hi everyone and welcome to another live session. My name is Antonio Leiva from antonioliva.com, and if you don't know about me, I help another Android developers to boost their careers by following different approaches with my products and services, and also with all the videos that I record every day and every week so that I can help you in many different ways. As you may know, these live videos, I've been doing them for a month or so, and I do one per week covering different topics from more beginner levels to more advanced. And today I want to talk about extension functions. You probably have heard about them if you are already working with Kotlin, but today I want to cover just the little basics and then show you some more complex examples. Some of them are probably more you know about them, you have heard about them before, but I want to do them from scratch so that you can understand how extension function works and lambdas with receivers and a lot of little concepts that we are going to learn today. So if you are interested, stay here with me and I'll show you all I know about this so that you can use it on your own projects and your own extension functions. So I'm sharing my screen and let's get started. Okay, so here what I'm using is just a simple test file where I'm doing some functions for you to understand how extension function works and how you can use them. Extension functions are just functions that can be applied to any class, even if you have access to the code of that function or not. That doesn't matter. It would substitute the utility classes and functions that we used in Java. But here we can make them look like regular functions, but in the end, they are just external to those classes. So they are really powerful and allow us to simplify our code in many different levels of ways. So the first example that I want to do is really simple. I want to have a test function here. And what I want to create is a function that checks whether an integer is even or is odd, just by knowing whether it can be divided by 2 and return 0 or not. So in Java, what we would probably do is to have a class. Don't pay much attention to it because this wouldn't be how you do it in Kotlin, but I'm going to write Java-styled code in Kotlin. We could have a class utils with some static functions. For that, in Kotlin, we need a companion object. And here, we could do function is even and receive here an integer and return a boolean saying whether this is even or not. And the result would be just x module 2 equals 0. And the same and very similar for is odd. For this, we can even use the previous function and do not is even. So when we want to use this, imagine we receive an integer from here, x int, we would have to do val is odd equals utils is odd x, or val is even equals utils is even, sorry, is even x. So as you can see, this can be done, but it's not really readable. You have to add all this code here, and the argument that is applying that function needs to be passed as an argument of the function. So it's a little verbose to to do something that we would probably want that the integer class has. But in the case of Java, we cannot add code to a class that we don't have access to its code, so it's not possible. In the case of Kotlin, we have a more powerful feature, which is extension functions, where we can manage to do something like this. X is even, it's odd, or X is even. And how we do this? How do we do this? This is thanks to the extension functions that we mentioned before. How do we implement an extension function? Just as a regular function, fun is odd. If you don't know about functions or variables yet, I had another previous live event where I talked about it, so be sure to check my channel and find it, because it will help you to understand all the steps that we are doing here. Find is odd. As functions can be first-level elements in our files, we don't need to have them inside a class as we had to do on Java. So it can be here, and then we will need to find a way to make this function to become as an extension function for integers. To do that, the only thing we need to do is to prepend the type that we are applying this function to. So int is odd. And now it magically works as a regular function in integer. It's that easy. If we start writing it, we'll see that the autocompletion already shows it as an option for every integer. It's that easy. And the only thing we need here left is to repeat this code we have here. But in this case, instead of using X, how do we refer to the object that has called this function? Just by using this module2 equals 0. And the same for it's even, sorry, in this case as it's odd, module2 equals 1, and it's even, we could do it one way or the other, it doesn't matter. Fun is even. This is an extension function. Equals not is odd, for example. As this is already an extension function for the integer, we can call it from here. It would be the same as doing no, this is odd. So that's awesome. Just with this simple thing, we can make objects and classes that we don't have access to its code to have new functions written by us. These extension functions can be public if we want to use them in our project, or can be private if we just want to use it in the file where they are implemented. This makes sense under some circumstances, so take it into account. Now moving to an example that may be more applicable to Android. Let's imagine this situation. We are having a ViewGroup. Well, let's start with a simpler one. We have a context here. And our goal is to simplify this typical code, toast with make test, context, my message, toast length short dot toast. So sorry. This is the line that we need to write a toast, but we all know that this is extremely verbose and that we'll probably use a an utility class with a function to hide all this. But in Kotlin, we can make it much, much easier thanks to the use of extension functions. You probably know about this one, but in any case, if it's your first time checking extension functions, this is a really nice example to start. I recommend you that, apart from watching it here, that you try it on your own, on a sample project, so that you can get all the ideas and all the concepts, and then be able to reply it by yourself. So here what we want is to convert this into just context, toast, and a message. Because the rest is probably something that you have to write every time, but that it's not giving you any value. So how you can do that? We'll follow the same process from fun toast. We're receiving a message, so message of type string. And also we want here to be applied to context, so context.toast. And now we just need to move, as you see, now toast can be used by all contexts. What I can do is to take this here, and the only problem we have is the context. Again, as this is being applied to a context object, the object is referenced using this. So that's great, right? With this simple code, we can now use toast in a more readable way, and in a much more clean way, that just by using all the API that the framework provides. But here we are missing one thing. We cannot change the length of the toast. We could write another function called longToast, for example, that changes this. Or another thing we can do is to add this length here, length of type int. But we now have a problem. We need to change all the calls to this function in the place where this is called. So here we will need to add, for instance, toast length short, and remove it from here. Besides, thanks Slava for letting me know through the chat, this needs to be changed by the message that the function is receiving. Message and length. What's the option that we have here, the alternative? Instead of forcing all places to identify the length that we are going to use, we can use something that is called default values. If we set an equals here, we can say toast length short, and by default, if we don't set any length, we can will use length short, and we have the other option that is adding a length here, toast length long. So thanks to default values, we don't need to do a method function overloading in the same way that we had to do in Java. Here we can avoid that and have different arguments for a function just by writing in once, instead of having to write every overload one after the other. So this is really helpful, and it will save you a lot of time and a lot of lines of code. The next one, and it will be the latest simple one, in case you are thinking whether this is going to be so simple all the time. We are getting a ViewGroup here, and we want to solve this this problem where we have a view. We want to inflate a view, and we use layout inflater. Sorry, layout inflater from ViewGroup.context, for instance, we can get the context from here. Inflate, the resource we are getting in from here. Layout, res, layout of type integer, layout, res, the root is the parent view group, so view group, and attached to root can be true or false. We are setting it to true here, for instance. So wouldn't it make more sense that view groups could directly inflate views instead of having to call it layout inflater, get the context that can always be taken from the view group, calling inflate and all that? It would be awesome if we could do something like view group dot inflate, get the layout res, and that's it. Much simpler and much more easy to the code is much more it's much easier to follow for the reader. So we again can solve this by using extension functions. So again, function inflate, we get the layout res from here. And we can copy all this into the inflate function. Again, what we are missing is the view group. So we apply this function to view groups. And instead of using view group directly here, we can use this.context. We can remove the this and this here. So these two lines are doing exactly the same, but this one is much more cleaner. And what if we want to change the attached to root? Sorry, the same as we did with the length for the toast. We can say here attach to root type boolean with a default value to true, and we use it here. In case we don't want to attach the inflated view, I'm missing another thing here, but I explain it now. In case we want to attach to root, we don't have to do anything or pass through because it's the default value. And if we don't want to attach it, sorry, because we are, for instance, in an adapter, we can say here false, and this is perfectly valid. The only problem we have here is that we are not returning the value from the inflater. If you see here, the type of this variable is unit, and we obviously want the view that is inflated from here, so we could return the value here and specify that this is returning a view. In the case of one-line functions, we can use the other variant of the functions that I also explained it in the previous video that I mentioned. We can convert this to expression body and have something like this if we want. And that's it. Now we have covered some simple examples, but today I want to do something a little more complex. The first thing that I want to explain is that, of course, functions can receive another function as an argument, can receive a lambda, and also could return lambdas. But in case we are showing some examples on how we can receive a lambda and start using that to create our own DSLs and create like a small language that we can use for our project. So the first thing that I need to explain is how we can pass a function as an argument. Imagine that we have instead of ViewGroup here, I have a view. It's again not very complicated. Imagine that we want to have a function. This is not very useful indeed, but just to show an example, view on click and receive here a lambda. As you may know, the set on click listener, thanks to the optimizations that Kotlin do over Java code, can be used as a lambda too. But here, I just want to. What I would just want to do is to show you how to create a function that receives a lambda as an argument, so that we have this as a base for the next example that will be a little more complicated. So function on click, and we have to receive a lambda here. So in our case, if you remember the set on click listener, first thing we have to do is to apply this to views, so that now this view can use on click. And here inside we would call to set on click listener. If you remember, the set on click listener uses this function on click, which is a function, we can ignore this. It's a function that receives a view and returns nothing. This is unit. It's also explained in that previous video that I mentioned. I'll leave it in the notes of this video so that you can go to that one. So here, what we want for our on click is to receive a function that receives a view and returns nothing, and this would be the listener, we can call it, for instance. And here, what we could do is just listener IT. Okay, as I mentioned, this is not extremely useful because we already have set on click listener, but that's the way to pass a lambda as an argument. I'm not going to get much into this, but if we want to do this a little more efficient, we could use the inline word here and call this crossing line. But in any case, this is not very important here, so let's continue with the example. I'm omitting the inline part in this video. Maybe I can do another video in the future with this reserved word so that we can understand a little better how it works. But I want to leave it aside today. I know that some of the functions that I'm doing are more efficient if I use inline, but for now, let's forget about it. So now we want to go further, and you may know that when we want to show a notification, for instance, and we have a context, we usually have to do something like this. Notification compat.builder. I always forget how to do that, so sorry if I have to do several tries. I'm going to receive the channel ID here so that I can't forget about it. Context and channel ID. And here, for instance, we can do, this would be the builder, and saving it into a variable so that we can see in a more clear way the steps that we have to do. And then we would do builder dot set content text, for instance. This is my notification. Set color, color, whatever, primary, for instance, or primary. Well, here I would need to get the get resources, context dot resources, get color. In any case, this is an example. It doesn't matter much what changes we do here. It would depend on okay. I probably need resource compat get color our color primary color primary. Okay. Sorry, context resources and no. Can be changed to access property syntax, but if I do that, I cannot keep set. I cannot keep joining the builder, but anyway, let's leave it like this. And one extra thing, set wherever, set icon, whatever. It doesn't matter this part. This is what we usually have to do implement a notification. And here with the builder, you would set the properties of this notification. And in the end, to save it to a notification, val notification equals builder.build. Of course, you can do all this without signing it to variables, but I want you to see what are the steps to create a notification. And finally, when we have the notification, we would have to do context compat get system service with the context and the service that is notification manager class.java. And I save this into a variable, notification manager. And finally, we'll do notification manager dot notify with the ID that we can also receive it from here, ID of type int with the ID and the notification. This can be null, so with the save call operator. So if you see here, we have to do a lot of steps, and the only important thing about this is this part, the part where we are setting the configuration of the notification, but the rest is all the time the same. We have to create a notification builder, then build it to get the notification, look for the notification manager, and then call notify. What if we could move all this boilerplate to a function and then just do this part in a lambda that we are receiving through an argument? So how we can do that? How can we do that? We can create a function called notify that receives a couple of things, the ID and the channel. And then we can make this an extension function of the context so that any context has a function that is called notify. So now we will be doing this context.notify the ID, whatever, and the string and the channel, whatever too. And what we want is to create a Lambda that allow us to just do this part instead of having to repeat everything. So we would have something like this. The ideal solution would be this one. Set context, set color, and set small icon. Okay, so what do we need to do to achieve this? The first thing, as we mentioned, is to get a lambda that we can call it the body, for instance, that receives something and returns. In our case, as we don't need to return anything from here, we return unit. Here we only want to do the configuration, but we are not returning anything. The thing that we will probably need is the notification that will be done as part of this boilerplate that we want to hide. So to make this, to be able to modify here the notification, what do we need to get as an argument for the Lambda? The builder, the notification compat dot builder. So we set it as the first argument of the function. As you can see here, something has changed, and we now received the notification builder as the IT argument of this function. So we could do here IT set context, content text, IT set color, and IT set smart icon. As we are no longer using the builder style, we can use the property access here so that it doesn't complain anymore. And that's it. But we can make it even simpler. If instead of receiving it as an IT, we receive it as a this, I'm sure that if you have been using Kotlin for some time, you probably know that there are some functions that receive the object here as a this instead of as an IT. So that way we could remove all this part. And how can we do that? The way I always like to explain it is that the same way that we can have extension functions, we can have something that would be like its equivalent to lambdas, extension lambdas to call it in a way, but usually they are called lambdas with receiver. But the way is the same. What we do to make this notify function to be part of the context, we just prepend it by separating it with a dot. The same that we are doing this with this context, with this function, we can do it with this lambda. If we want this to behave as an extension lambda or as a lambda with receiver, we just need to take this out of the parentheses and prepend it instead. And you see that now this IT has changed by this. Just with this, we have managed to achieve what we were trying to be able to do all this, the boilerplate inside a function, but we still have to move it to the function, of course. So we just not need here to do this. We cut it from here and paste it here. The context now is this. And this part is the part that we are doing in the extension function, sorry, in the lambda with receiver. So instead of doing builder, set context, set color, set smile icon, as this is a lambda whose receiver is notification builder, this means that the notification compat builder now can call this function. So builder dot body, and when this is called, this part of the code will be called also, and will configure the notification with all the things that we have decided here. Finally, here instead of context also we use this. And with this, we would have hidden all the repetitive part to an extension function that is also receiving a lambda with receiver. This concept, this idea, you probably have already seen it and used it in functions like let or apply or run, even with. Also, there are many functions that use this idea to be able to call a lambda that applies to an object that is calling that function. So let's see an example. For instance, let's see I'm creating a test view, val text view. The caps lock is ignoring me. 1 second. Text view equals text view, which receives a context, and we want to do some configurations over this test view. In the test view class, we don't have a builder to do that in an easier way, but it doesn't matter in Kotlin because we have the function called apply, where we can apply some configurations to this test view, and the return of the function will still be a text view like this. So we can do here text equals hello, or text size equals 28 and test I don't know, whatever, and hint equals hint. It doesn't matter. The important part is how to create all this so that we can get the text view as a disk here, and then apply some configuration over it without having to repeat text view.test, text view.setSize, text view.hint. So what we are doing here is to implement this apply function. I'm going to call it apply2 so that it doesn't collide with the one in the library, in the Kotlin library. And the first thing we need to do is to call it apply2. First, I'm not going to do it generic. I'm going to do it only applicable to text views so that we understand how to do it, and then we'll cover the generics, because do the two things at the same time is pretty complex. So let's go step by step. We have an apply2 function. As we want this function to be applied to test view, then let's prepend the test view here. And now test view can call this apply2 function. But obviously it's not working because this is not receiving any argument. The argument that it needs to receive is the text view, right? So a lambda that applies to a text view. So body text view unit. We are following a little the same process that we did before, so that it can help you understand. As you will have seen a couple of examples, maybe it's easier for you to understand how all this works. So here, now we are receiving the test view as an it.text, it.textSize, and it.hint. Of course, this is not ideal because we have to repeat it several times, but we'll change it later. And the third thing, so that this works completely, or how we are doing it now, is that this function needs to return the text view so that it's safe here. So text view, and the definition of the function is already finished. Now we need to implement it, but these functions are usually more difficult to declare than to implement, because the implementation is just to call body with the text view, which in our case is this, because it's the object that is calling this function, and then return this. And that's it. It doesn't need anything else. But again, to convert this from IT to this, we just need to convert this to an extension lambda, or a lambda with receivers. So we extract this from here and prepend it. It's that easy. Now all this IT is no longer required. As you can see here, this is already, we are receiving already the text view as a reference, so we don't need to use IT anymore. Okay, so we have managed to do this function apply to work with text views. But imagine that we want to do the same with strings. Val text view, sorry, val string of type strings equals to hello dot apply to, and do whatever we want here. For instance, I don't know, and delete or replace. No, well, as I don't have autocomplete here, I'm not sure, but for instance, replace this with this with this. Later we'll see how else we can do that. You can imagine it's the same structure. We have a block where we are doing some things over the string, so that we can then save in this variable the string, but modify it with the configuration that we need. How can we change all these functions so that it's generic, so that it applies to all types? We just need to use a generic type that we can call T, and substitute every place where we are using test view by a T. T here, and T here. And that's it. As you can see now, it can be used with strings, but it could be used potentially with any types of values. So again, I don't know how long I have been for now, but in any case, I'm going to explain another one that is a little different, so that you can understand how other functions work. We have applied that. If we go to the original implementation, you will see that it's pretty similar. It has some contracts here that maybe we can talk about them in another video, the inline that I mentioned before, but it's just calling block and then returning this. One difference that I'm seeing here now that I forgot to mention is that we are still calling it this function as if it was a regular lambda instead of a lambda with receivers. Kotlin allows you to call the lambdas with receivers in both ways, by passing the argument as through the parentheses, or you can do it the other way, this dot body. In our case, as this dot body is the same as body, we could leave it like this. And that would be exactly the same as apply is implemented. There are others, for instance, we can try with let that have a couple of differences. If we use let, for instance, with another text view, but we are saving here a different thing. Let's see it now. Text view dot context dot let, and here we could do all this and then finally return text. The first different thing is that let, instead of receiving this, receives IT, which you already know that is a little easier. IT, IT, IT. Easier to implement, I mean, but not easier to write. And we are saving this in a variable, val result. What do you think that the type of this variable will be? You can always check it doing Control J, but you can see here this is a char sequence, but you can also do specify type explicitly, and that way you can have it a little more clear. So the difference are two. The first one is that apply receives this and let receives IT, and the second one is that the apply function returns itself, the same object that has called this function, while let returns the value of the last line of the lambda. So in this case, it's returning IT text, which is a char sequence, or yeah, let's leave it like a char sequence. So again, to implement let, it will be a little different. We will have the function let. I'm doing it not generic first, and then we'll change it to generic. Let, which is applied in our case to a text view. The text view is the one that is calling let, receives a body that is receiving a text view and returning the previous one returned unit because we weren't using the result, but in this case we are using the result of the function. So in this case we are returning a char sequence, so let's use char sequence here. And then of course it returns a char sequence. This function will return the value that the lambda is returning. So the code will be kind of similar to the previous one, but we return a different thing. We would do just return body, receiving this as an argument. So it will return the value of this lambda. We can, of course, do this, write this like this. And maybe it's a little easier. So we apply the lambda that we receive and return the value of this lambda. So now we have it working for this example, but we can generify it again. But in this case, instead of having just one generic type, we have two, the text view and the char sequence. So we use here T and U, and when we have text view, we write T, T and T, and when we have char sequence, we use U, U, U. And it's that easy with this. We just have a function that is very similar to the let that is originally in the Kotlin library. As you can see, this is a little more advanced because you have to understand generics and you have to understand lambdas and lambdas with receivers. But if you go step by step and little by little, it's easier to understand all the concepts and apply them to the function. Remember what I mentioned at the beginning, that the best way to master all these things is to do it on your own. I don't think that you can get all the ideas just by watching this video. What I recommend you is that you open Android Studio and try to repeat it with me and to understand it step by step. And if you have any questions, you can use the comments below and we can see it. So I think that's everything I wanted to show you today. I'm getting back to show my screen, my camera. Let me see how this is done. Stop sharing. Right, so I'm back here. So I hope that you have learned something from this content. I try to do things from the simplest one to the more complex ones, so that you all can get something from the video, from the ones that are still starting with extension functions to the ones that already know the basics but want to master them. I really hope that you enjoyed it, and if you have any questions, you can use the comments below, and here below too you can subscribe to my channel so that you can watch and not to miss the videos that I do weekly. Again, if you have any ideas of what you want me to talk in these live events, please let me know in the comments, and I'll be very happy to take them into account and to talk about them in future weeks. Thank you so much and see you soon. Bye.